Hey, what's going on, guys? Let's do this problem right here. The first question is asking a sound from a single source can reach point O by two different paths. One path is 20-meter long and the second path is 21-meter long. The sound destructively interferes at point O. What is the minimum frequency of the source if the speed of the sound is 340 meter per second? So first we have to know what is when the waves will destructively interference. So if you look at this, like lambda by 2, 3 lambda by 2, destructive interference pattern is going to be going like this, right? 3 by 2, 5 by 2, lambda, and it's going on, so on and on, right? Like all the odd numbers in the top. So that's how it's going to be. So here we have to look at the first one. That's they are asking for, right? First one occurs it right here. So for example, if two waves travel like this, so two waves are traveling. So the first, according to their information, this one is occurring at 20 meter. For this one, is occurring at 21 meter from here. So it's going to be something like here, right? It's going to happen right, like here. So let's find the lambda first. So lambda by 2 is equal to 1 meter. The difference, if you look at the difference, that is 1 meter. So that's the one we have to take. So this is going to be lambda by 2 is going to be 1 meter. Therefore, lambda is equal to 2 meter. So we have the lambda right now. All we have to find is frequency. Frequency, so V is equal to F lambda. F is equal to V over lambda. And then the velocity of the sound is given, that's 340. 340 divided by 2, that gives us 170 hertz. And that is the answer for the first question. So let's do the second question. Second question is asking, consider a pipe length L that is open at both ends. So it open at both ends. What are the wavelengths of three lowest pitch tones produced by this pipe, right? So lowest pitch. When will the lowest pitch occurs? Lowest pitch occurs when the frequency is high. So we have to know this frequency is high when it's have antinodes. Like for example, if I throw the waves right here, so we need first three antinodes of this one. So this is going to be open. Okay. So antinodes are the one on top. This is antinode and this is node. Right? So according to their question, they are asking what are the three lowest pitch tones produced by this pipe. So the first one is going to be this length. The second one is going to be this length right here, the extremas, right? And then the third one is going to be right here. And first of all, if you look at the wavelength of this one, what is the wavelength for this one? This is lambda by 2. This distance is lambda by 2, and this one is in the middle, so it's going to be lambda. This is lambda, and from here to here, one full wave and a half wave, right? So 3 lambda by 2. So if I calculate this one, if I equate this one to L, L is the pipe's length. In each case, we take this one equal to L. First, we take lambda by 2 is equal to L. That gives us lambda is equal to 2L. And the second one, we take lambda is equal to L. That's going to be just as it is. And the third one, we take 3 lambda by 2 is equal to L. And that's going to give us lambda is equal to 2L by 3. So it's going to be the first three lowest pitch tones are going to be 2L, L, and 2L by 3. And that's how we find these answers. And let's do the last question. The pipe is 0.9 meter long and is open at one end and closed at the other end. So the pipe, okay, we have pipe right here. It's open at one end and closed at the other end. They are saying that closed at the other end, if it resonates with the tone whose wavelength is 0.72 meter. So they have given the wavelength 0.72 meter, and they have given the length of the pipe, that is 0.90 meter, right? Then 0.72 meter. What is the wavelength of the next higher overtone in this pipe? So where they are asking for the next higher overtone. First of all, we have to figure out the pattern. So in a closed pipe like this, like one closed and the other one is open, we are going to have always nodes in this one. The closed one is going to have the nodes always, and the open end is going to be having anti-nodes always. So here the first one is going to be this one, that is lambda by 4. So what is going to be the next one? Next one is going to be this one right here, right? This is lambda by 4, and this is lambda by 2 plus lambda by 4. Lambda by 2 plus lambda by 4, that gives us 3 lambda by 4. 3 lambda by 4, and if you see, the next one is going to be 5 lambda by 4. And if you see the pattern right now, it's like odd numbers on the numerator. 1, 3, 5, 7, 9, 11, and it goes on and on like that, right? And here we had to, what we had to do is we had to equate this lambda and see where are we getting this value. First one, if I equate this one to this one, lambda by 4 is equal to 0.9. This gives us lambda is 0.36. That's not what we have. So we have to figure out what's the next one. So 3 lambda by 4, if I multiply 0.9 by 4, it's going to be 3.6, and divide by 3, that's going to be 1.2. That's not this value. Let's do for each 5 lambda by 4. 4 times 0.9, that's going to be 3.6. Divided by 5, that gives us this value. So this matches this one right here. So the next one is going to be 7 lambda by 4. That's what the question is asking. What is the wavelength of the next higher overtone in this pipe? So to find this one, I have to equate this one to 0.90. And if I equate this one, lambda is equal to 0.90 times 4 divided by 7. That gives us 0.51 meter. And that is the answer for this question. I hope you guys like this video. See you next time.